Welcome to Math Club with Mr. Paul, where we make mathematics simple, fun, and easy to understand. Suppose I have some mangoes and I don't know how many. How can I represent that unknown number? Well, mathematicians use letters to represent unknown quantities. This idea is called algebra. What then is algebra? Algebra is a branch of mathematics that uses letters, symbols, numbers to represent and solve problems involving unknown quantities. For example, instead of saying I have an unknown number of oranges, I could say I have X number of oranges. Isn't that simple? Instead of saying 5 plus an unknown number would give me 21, I could say 5 plus y is equal to 21. Isn't that simple? Well, to proceed further, it would be very important that we discuss some of the common terms that are used in algebra. Some of the common terms used in algebra include: number 1, a variable. A variable is a letter used to represent an unknown quantity. You remember how I said 5 plus y or 5 plus x is equal to 21? That x is the variable. Okay? A variable is a letter used to represent an unknown quantity. It could be x, it could be y, it could be a, b, d, w, z, etc. The next term we'll be looking at is constant. When we say constant, what do we mean? A constant is a fixed number whose value does not change. Its value does not change. It can be 1, it can be 2, it can be 4, 6, 8, 21, 300, etc. That is a constant. Its value does not change. I'm pretty sure you understood that. So quickly, here's a quick task for you. Solve those quick tasks and then we proceed from there. Identify the variable in each of the following. X plus 3. Which is the variable? 7 minus y. Which is the variable? Also, I'd like you to identify the constant in each of the following as well. First one is a plus 8, and the second one is 4m minus 2. Wow, beautiful. Now that you've done that successfully, you can see that it's quite easy. So let's proceed further to discuss more of the terms. We've just listed 2, variable and constant. Number 3 we'll be looking at is term. You must have heard of the word term. What is a term? A term is a variable, constant, or a combination of variables and constant connected by multiplication only. Underline the word multiplication only. These variables or constant must be connected by multiplication only. For example, 3y, that's a term. 2x, that's a term. 3x, that's a term. 5y, that's a term. Guess what? You can also have 7 as a term. You can also have a as a term on its own, etc. They are connected by multiplication only. The next thing we'll be discussing is algebraic expressions. Well, unlike terms, algebraic expressions are a group of terms connected by either addition or subtraction. For example, 3x plus 5, 2a minus 7, 4x plus 3y. All these are algebraic expressions. With that being said, I'd like you to quickly identify the terms in the following algebraic expressions. Number 1 is 6x plus 2. Next is 3a minus 5b. And then we have 2x plus 3y minus 7. Identify just the algebraic or the term in each of this. Quickly do that with the speed of light. Beautiful and amazing. Now that you've done that, let's go to the next thing we are going to be discussing. We discussed about 4 now, right? We've discussed about 4 now. We discussed variable, constant, terms, and algebraic expression. Number 5, like terms. Like terms are terms that have the same variable or terms whose power are raised to the same number. Okay, they have the same variable or they are raised to the same power. For example, 3x and 5x, they have the same variable. 4a and 7a, they also have the same variable. 2y squared, you see now that the variable y is raised to the power of what? 2. And 6y squared, the variable in 6y squared is y, and that y is also raised to the power of what? 2. You see, in this case we have both variables are same and both variables are raised to the same power, therefore they are also considered like terms. Now, number 6, we are going to be discussing unlike terms, meaning these terms are not the same. It's just the opposite of what we have in like terms. What are unlike terms? Unlike terms are terms with different variables, or they are terms that are raised to different powers. For example, if I have 3x and 5y, you see that the variables there are different. 3x, 5y. X is the variable in 3x, y is the variable in 5y. They are different. That's what we call an unlike term. Also, I could have 4a and 7a squared. This one is a tricky one. You see that if you look at the variable in 4a is a, the variable in 7a squared is also a, but they are not like 10. Please do not mistake them. They are not like 10. Why? Because the variable in 7a is raised to the power of 2. So there we have 7a squared. While on the other side we have 4a. So you see that their powers are not the same. Therefore, they are also considered to be unlike terms. We also have, for example, 2m and 6n. Letter m different from letter n. Therefore, the variables are different. So that settles it. It's an unlike term. But then again, why are we even bothered about this term, like terms, unlike terms? Why are we even bothered about them? We are bothered because we'll be needing each of this term when we get to the next phase, which is grouping of like terms. Because whether you like it or not, terms have to be grouped according to their family. You come from a family and your family bear your surname. I also have my family, and members of my family, we have a common name as well, which is our surname. You get it now? So we'd like to identify things according to their family. Therefore, it's very important we understand terms, like terms, unlike terms, and now let's move further to grouping of like terms. This is the part where we begin to solve. For example, the first one we'll be looking at is 3x plus 8x. Now you can clearly see, because they are like terms, we have the variable here x and another variable here x. So because both variables are like terms, we can just go ahead and then say 3 plus 8. That would give us 11. And since they are like terms, x and x, we just go ahead and add our x. Therefore, 3x plus 8x is going to give us 11x. Isn't that simple? Another way you could look at it is, let's say 5a plus 4a. 5a plus 4a, let's assume that the a represents apples. 5 apples plus 4 apples. What's that going to give you? Is it 9 apple? It's not going to be 9 apples. Don't mind me, I'm just kidding. Of course it's going to be 9 apples. So you write just 9 apples. So when you are grouping like terms, since they are like terms, you just pick the constants and add them or subtract them, and then pick one of the variables to represent the variables because they are like terms. Let's look at another example. Let's say we have 4a plus 7a minus 2a. What is this going to be? This is going to be, because they are all like terms, we are just going to group them as well. But then in grouping them, you notice that we have an addition sign there. We also have a subtraction sign there. We are not going to do away with BODMAS. Okay? So we are going to do addition first before subtraction. Therefore, in adding these up, we have 4 plus 7a. That's going to give us 11a, then minus 2a. So 11a minus 2a is going to give us 9a. Quite easily done. Now let's go to the next. Let's say we have another one which is 6y plus 3x plus 2. Okay, let's say 2y. It's becoming interesting now. If you look at what we have there closely, we have 6y plus 3x plus 2y. Are the variables all the same? Beautiful, the variables are not all the same. So you are going to group like terms and unlike terms. Okay, so let's collect those that are like. We have 6y, so you have here 6y. Which other variable has the same, is the same as 6y? Beautiful, 2y. So we say 6y plus 2y. Then we can now put plus 3x. And what is this going to give us? 6y plus 2y, 8y. Beautiful. So we have 8y, then plus 3x. That's where you leave it at. Yeah, that's where you leave it. Because y and x are not the same. So your final answer there is 8y plus 3y. And someone is saying why, isn't it? Someone is asking why. Okay, beautiful. Let me tell you why. If I have 5 oranges and 2 apples, 5 oranges and 2 apples, what do I have? Will I say 5 plus 2, that's 7, and then I would say 5 orange apples? I'm not going to say 5 orange apples. Or will I say 5 plus 2, that's 7, then I'll say 7 orange apples? No, I'm not going to say 7 orange apples. What am I going to say? I have 5 oranges and 2 apples. You still specify what they are. Therefore, because they are unlike terms, therefore we leave it that way. 8y plus 3x. Is that clear? Some other persons would decide to turn it the other way, especially since in the arrangement of your alphabets, x comes before y. You could say 3x plus 8y. It's still the same thing. Okay? I'm sure you understood that. Okay, let's solve the next one and see. Let's say we have 4x plus 3y plus 7x plus 2y. I believe we have smart guys in the house. You can solve it, okay? Are you going to beat me to it? So let's go. Just join me, don't mind me. I'm kidding. First thing we are going to do is to collect our like terms. Beautiful, you are following. So which should we go for? Let's go for x first, right? Okay, so we have 4x. Is there any other one with x? Beautiful, 7. So we say plus 7x. Any other x? No. Then we go to y. What's the first y we have? The first y we have is 3y. Therefore we have plus 3y. And then the next y is 2y. So we have plus 2y. So you see that they are close now. we have our like terms close to each other. So we go ahead. 4x plus 7x is going to give us what? Remember, you just pick the constants, right? Since they are like terms. So 4x plus 7x will give us 11x. Then plus, we also have 3y and 2y. Both of them are also like terms. So we just pick the constant, which is 3 plus 2. That's going to give us what? 5. And then we bring down the variable, which is y. Therefore, this whole thing here, my dear, is just equal to 11x plus 5y. Isn't that simple? Okay, but then I must warn you, there are common mistakes that students do. For example, they may have something like 3x plus 5y, and then you see some students saying, okay, 3 plus 5 is 8, so they write 8, and then the variables are x and y, then they write x, y. Is this correct? I know you now know better, and you know this is not correct. So avoid this mistake. Do not do this mistake, because now you know better, isn't it? Now that you know better, I would like you to solve the following practice questions for me. They are displayed on the screen. Please go ahead and solve. Until I come your way next time, remember, this is Math O'Clock with Mr. Paul, where we make mathematics simple, easy, fun for everyone. It is simple, it is fun, and then it is easy for everyone to understand. Don't forget to like, share, subscribe, and comment. See you next time.